Welcome back, Chemistry 30. This is the 6.1 booklet for Unit 3, Energy Changes in Chemical Reactions. The objective for this is to look at examples of energy, law of conservation of energy, chemical potential energy, heat, temperature, calorie, joule, and specific heat. Explain what energy is and distinguish between potential and kinetic energy. Recognize that energy changes are associated with chemical reactions. Relate chemical potential energy to the heat lost or gained in a chemical reaction. Distinguish between heat and temperature. And calculate the amount of heat or absorbed by a substance when its temperature changes. Okay, so first of all, what is energy? It's the ability to produce work, to do work or produce heat. And the types of energy that you may have seen before, kinetic and potential energy. The word kinetic implies movement, so it's the energy due to motion. So for example, a roller coaster going down a hill. Potential energy, stored energy due to the position, so kind of at the top part of a roller coaster, it has all the stored energy, because if it goes over the edge, it turns into kinetic energy. Or a condition, so for example, a stretched elastic band would have a lot of stored energy due to its condition. And of course, the law of conservation of energy says that energy is simply converted from one form to another. We can't create it from nothing, nor can we obliterate it or destroy it. Okay, and I gave an example of the roller coaster here using the law of conservation of energy. So if we imagine the very top of the initial part of a roller coaster, all of the energy would be stored, 100%. And if you're motionless for that moment in time at the top, kinetic energy is 0. At the very bottom, all of our energy would be moving energy or kinetic energy, and I'd have 0 stored energy. Then of course anywhere in between there, could be 50-50, 60-40, etc. And of course in real life there we don't have a perfect conversion here, because if we can hear the rollers of the roller coaster, we know there's sound energy, heat energy, friction, etc. So it's not a perfect conversion there, because some energy is lost due to changing into one of these forms over here. In terms of chemistry, energy, we're looking at energy stored in a substance due to its composition. So for example, food items have a certain amount of stored energy that our body uses to get energy from, etc. Or we can look at the octane molecule in gasoline. It has a lot of stored energy due to the bonding that it has, all the carbon and hydrogens linked together. At the end of this booklet, I draw a diagram of it, and I'll show that to you. All of the chains of carbons and hydrogen in an octane molecule, those all contain energy. Heat and temperature, what's the difference? Heat is energy. And if we're looking at heat, how it moves from hot objects to cooler objects. So it's this energy movement. Temperature is a measure of how fast the molecules are moving. So the energy, the average kinetic energy, the average moving energy of particles. So a thermometer outside would be measuring the kinetic energy of the air molecules moving around it. Okay, so there's definitely two different things. Calorie, notice it's a small c calorie, so it's not the same calorie that's on the back of a bag of chips. This is what I refer to as a scientific calorie. It has a small c, and it's defined as the amount of heat required to raise the temperature of 1 gram of water by 1 degree C. And how is that related to that calorie that's on the back of food items, whether it's a bag of chips or granola bar, etc.? 1,000 of these scientific calories is equal to 1 big calorie. So if you have a 500 calorie burger, that's what it says on the wrapping paper, that actually is 500,000 scientific calories. So the nutritional calorie, it's a little nicer numbers to work with, whereas scientific calorie, it's a smaller unit, therefore we need a lot of, a bigger number there to discuss that one. Joule, calorie is the old imperial system in measuring energy, even though we still use it today. The metric system, or System International, is joule. So we can figure out what we want to let equal 1 here. 1 joule is 0.2390 calories, or 1 calorie is 4.184 joules. And you recall earlier that the calorie is the amount of energy required to raise 1 gram of water by 1 degree C. That's the number there. And if you look back at a couple of things here, you will see that the specific heat of liquid water is that number. The amount of heat required to raise 1 gram of water to a temperature of 1 degree C, 4.184 joules. Okay, and then of course we could convert between the two. So if we take a look at this handout that you have, I just copied this and put it on a piece of paper for you. So here we have that 1 joule equals 0.2390 calories. So my two conversion factors, 1 joule over 0.2390 or 0.2390 over 1 joule. Or if I'm using this conversion, 1 calorie over 4.184 joules, or 4.184 joules over 1 calorie. 1 kilojoule is of course 1,000 joules, etc. So we can use that when figuring out these next problems. So a fast food item contains 544 nutritional calories, so that's the big C calories. Convert this energy to calories and to joules. So first of all, if you look over here, changing it into scientific calories first of all, we know that 1 big cal is equal to 1,000 little cals, so that's 544,000 calories. And then of course using one of those conversions there, going from calories to joules, so see calories cancel and I'm left with the unit that I want. 4.184 joules is what the number is on top. Multiplied out, I get 2.28 times 10 to the 6 joules. Okay, so there's a few more questions here. I think I'll stop the video here. We'll bring that back in part 2. See if you can figure out the answers for B and C when you read them. Okay, see you shortly.